See, in what we have done in our previous session, we have majorly learned, okay, what is meant by, what I can say, data analytics. And along with that, we have also tried to understand various other things like, okay, we have tried to understand, what is meant by, statistics. What are the various types of statistics? We have majorly learned something called as, descriptive statistics, and we have majorly tried to understand what is meant by measure of dispersion and measure of central tendency. So these are some things that we have understood in our previous session. Okay. So in our session, in this particular session, we will be trying to understand the rest of the what I can say, task. That is, okay. Meanwhile, I think my camera is not on. Let me put my camera as on. I will also share my screen as well. Beautiful, beautiful, beautiful. Thank you very much for coming on this particular thing. So what I was actually trying to say is, in our previous session, we have understood, various things, okay, related to data analytics as well as the descriptive statistics. So today it is going to be a little bit of extension of descriptive statistics. And today we are also going to understand the various transformation that is required. See, yesterday I was speaking about, various kinds of distribution and all these kind of things. But when it comes to machine learning, there are specific standards, there are specific, what I can say, requirements, which we call them as assumptions, of, what I can say, a specific machine learning algorithm. So today we will be trying to understand, if we don't follow these, assumptions, what is going to happen? Point number one. Point number two, we will be also trying to understand, what are the various types of options we have to transform the data. So today we will be understanding majorly, what I can say, cleaning the data, preparing your data, how to prepare the data and all these kind of things. So now let us go to our, this thing, what I can say, this thing, let me say, white screen. Okay, that's good. So yesterday, what we have understood is, we have understood something called as, okay, this thing, what I can say, measure of dispersion, that is mean, median, okay, mode. Okay. So these are some things that we have understood in our previous session. So now this particular mean, median, mode is very important. Okay. The reason why, okay, these are very important, you will be very, you will be learning them, okay, right now in a very interesting manner. So whenever you have a machine learning algorithm, let's assume you have a machine learning algorithm. So there are a lot of machine learning algorithms. There is linear regression, there is logistic regression, there is, what I can say, k-means, okay, and so on. There are a lot of machine learning algorithms. When you speak these machine learning algorithms, they are all different. So they are like your fingers. One is good at one specific task. Okay. One is good at one specific task. Okay. And there are also some machine learning algorithms which you may feel that these are not important itself. Something like this. So what I am trying to say is, these machine learning algorithm requires a specific process. Okay, the specific process. So this process is called as CRISP-DM. CRISP-DM. What is meant by this CRISP-DM? Let me help you on this. So this is basically called as international business, what I can say, standards for your data mining. This is your international standards. See, whatever we are going to do, okay, and understand as per international standards. Because see, if you are doing any specific transformation, you are not going to just do the transformation and prepare your data as you want. Okay, like if you want to create a data analytics platform or something like that, you are not going to get the data first, then do the do the some dashboarding or visualization, then you do the transformation, then you do the machine learning. No, no, no. There is a specific process which is being laid out by the international benchmark. Every single data and analyst who are available in this particular universe, okay, need to follow this particular CRISP-DM technique. Okay, so what is meant by this CRISP-DM technique? Let me show you on this particular part. Meanwhile, let me turn off my VPN. Okay, see what is meant by this this thing. What I can say, CRISP-DM. CRISP-DM stands for beautiful. It is going to stand for the cross-industry standard process for data mining. So any company, you go to any company, if you go for Infosys, if you go for Accenture, if you go for BCG, any company, okay, they are going to use this particular process. Okay. See what they say or what we follow is we follow this particular process. First, we sit with the data, every single person, either it is done by your business analyst, 99.99% of the time you do the same process, you basically sit with the business. You ask the business what you want, what is your problem. Then what he is going to do is he's going to provide the problem. The business analyst will sit and he will understand the problem and he will communicate it to the data scientist and data analyst, saying this is the actual problem and this is how we have to solve it. Then the data analyst will get the data, he will prepare the data, he will he will do the transformation, he will get the data in the right format, okay, and then he is going to do the data modeling. Okay, he will build the data science models, he will build the machine learning models, he will do the predictive analytics. All of them are basically modeling itself. And then when he is done with this particular data modeling, then that particular model is going to be evaluated. Why it is going to be evaluated? Let me give you a small idea. So for example, if you are building a machine learning algorithm to predict your salary. So for example, if you are having XYZ number of years of experience and you have this thing, what I can say, XYZ years of the background of technology experience. In that case, what need to be your salary? So you have some data, you are going to take those kind of data, you analyze it, and then you are going to predict, saying that XYZ need to be the salary. So here, what is going to happen is, if the salary is low, no one is ready to join your organization. Agree with me? So for example, if the industrial salary for data scientist is something like 6 to 7 lakhs or something like that. If you try to provide 2.5 lakhs, anyone will join? No, right? Similarly, similarly, we have other consequences as well. Like if you are going to provide more salary, for example, there might be a guy who might be asking for, who might be looking for something like 15 lakhs or 20 lakhs. He may ask you 15 lakhs or 20 lakhs, but inherently what is the industrial standards? Maybe every single company is providing a really good data scientist something like 6 to 7 lakhs, but unfortunately, okay, you have provided 15 lakhs knowingly or unknowingly. So who is under loss? You are under loss, because he would have joined the organization for a very minimum salary of something like 6 to 7 lakhs, but you provided 15 lakhs, nearly double. The person who is joining your organization, he is happy. Agree with me? So for these kind of things, there is something called as evaluation. We do any data science model that we build, we do something called as evaluation. There are a lot of evaluation techniques. Okay, confusion matrix. There is, what I can say, a mean squared error. There is also something called as F1 score, accuracy, ROC. We will be trying to understand them in later session. And last but not the least, when the business is going to approve, then when the business is going to say, yes, this is working fine. Till then, what we are going to do is, we are going to do the same process. We talk with the business, understand the problem, okay, prepare the data, model the data, evaluate the data. And this particular process will go on. And when he's going to say, okay, Sangmesh, okay, guys, this is absolutely fine with me, I'm okay with it. Then what you do is you push it to development. You push it to production. You create applications. You create, what I can say, apps. You create certain dashboards and reports. Until then, you are not going to touch. Until then, you are not going to touch these models, okay, into the development environment. I hope people are able to understand what I'm actually trying to say. Any questions on the process of CRISP DM? This is the standard process. You may join any organization. You may join any country in the entire universe. If you are talking to a what I can say, data analyst who is based in Romania, he will be following the same. If you are talking to a data analyst who is based in US, he will be doing the same. Any questions? Abhishek, any questions? Amjad, any questions? Bhuvanesh, any questions? Okay.
No,
And Uday Kumar?
the things are clear so far.
No, sir.
For data analytics software installation, Windows required, Windows 10 required. Normally, Windows 10, the reason is, there are a lot of pieces of softwares these days which are, what I can say, which are available, and as minimum requirement is Windows 10. Okay. So I got only one response. I think Uday Kumar. How about rest? Abhishek? Good?
Yes, sir,
Amjad,
I
good?
have Windows 10
Okay.
installed.
Bhuvanesh, how about you? Bhuvanesh, good?
Yes, sir. Very good.
Okay. See, just try to understand this. Talking with the business, okay, this particular thing, talking with the business is something that we have not discussed. But understanding your data, yes, we have done it. Agree with me? Descriptive statistics, mean, median, mode, standard deviation, variance, histogram. These are all about understanding your data. Agree with me? Agree with me? Okay. So now what we are going to do is, now we are going to try to understand the second step, or that is your data preparation. How do we prepare our data? And what are the different type of transformations that are required, and how to basically clean your data? Either it is your text data, either it is your what I can say, numerical data. How to clean this and why to clean this, and what is meant by outliers, how to identify these outliers, and how to remove these outliers. So these are some things that we are going to focus here. Okay. So let me close this particular part. So we are going to understand everything, theoretical concepts in this session. Okay. And when we are doing our, what I can say, training on a specific tool, like when I speak about data imputation, it can be done even using Excel as well. It can be done using Python as well. So what I am saying is, I am going to give you an understanding how to do after the training. Okay, when we are done with Excel and all, okay, if you want to replicate the same, okay, if you want to do a specific transformation, okay, how to do that particular transformation, I'll be able to teach it when we are understanding a specific, when we completely understand that specific tool, we'll be able to do that particular thing. Okay, so now what we are going to do is, now we have understood something called as CRISP-DM. Okay, see what is meant by this CRISP-DM. Let me help you on this. CRISP-DM is one of your, look at this. CRISP-DM is one of your data analysis process. It is your data analysis process. Okay. From now, we tend to ask questions. Okay, we tend to ask questions that, okay, so let's assume you are creating a linear model or a linear regression. Okay, so what is the process? We tend to ask, we tend to trick every single person who is even an experienced candidate, or even a, what I can say, a very naive guy, a rookie. We try to ask this particular question: how do you build a linear regression model? So there are two types of people who tend to answer this. Okay, so there are one type of people, what they will say is, sir, I will open my Python and I will say import NumPy and all these kind of things. I will load all my libraries, then I will load my CSV data, and I will basically get this particular data modeling and do the evaluation. Sorry, this is one type of people. Second, what they do is, they will try to understand why there is a linear model required, why there is a specific machine learning algorithm that is required. They will try to understand that. Then they will try to do the data understanding. They will understand the data. After understanding the data, what they do is, they will prepare the data. When they are done with the data preparation, then only they will go for modeling. Okay, whenever in your interview, whenever a person is going to ask you, okay, so I have a data set and I want to create a machine learning algorithm. Okay, basically a specific, any random machine learning algorithm. Okay, when he is going to say, it's your duty not to explain things like, okay, importing the data, you are doing this kind of things and that kind of thing. No, you have to align everything using the CRISP-DM technique. You have to answer, look at this, you have to answer things using this CRISP-DM techniques. So that's the reason 90% of the people get rejected in the first round itself, because they don't even know the basic concepts of CRISP-DM. Even being very frank with you, I have met the entry level rookies as well, rookie data scientist, naive data scientist who even don't know, even they have joined the organization, they don't know about this CRISP-DM technique, how it is actually working. Okay, so for that specific reason, it's a very really important thing. It's a really important thing, and it's a industrial benchmark that we are going to follow. Okay, so any answer that you are going to provide, keep this particular thing. Are you explaining the CRISP-DM technique? Okay, when these kind of questions like how do you implement a data science model and all this kind, don't directly focus. Most of the software engineers, they say, hey, I am really good software engineer, so they will only speak about the development part. No, there is a huge architecture. There is a huge architecture. So development, that is an application, is only a tip of an iceberg. There are a lot of things which will go behind this. Okay, and you have to explain all the process. Okay, so I hope now people got some clarity how to answer things. Okay, whenever an interviewer throw questions, this is how you have to deal with it. Agree with me? Okay, agree with me? Uday Kumar, okay, Bhuvanesh. I am not getting any response from Bhuvanesh as well as Uday Kumar. Okay, just give me a confirmation. Uday Kumar is able to respond me over a chat, but Bhuvanesh is one guy, okay, who is actually not responding me. See, I believe in 100% paisa vasool. Okay, if you are attending my session, okay, even though you are paying 1 crore or even though you are paying 1 rupee, I don't care. But if you are investing your time, money, and energy, okay, it need to be really efficient. Okay, so because see, I am not a easy guy. I worked as a data scientist for 3 different organizations. Okay, today I run my own company. Today I hire data scientists for my organization. Okay, we have something like a team of 5 people. Okay, and we are doing a really good business, being very frank with you. Okay, so I hope you are able to understand what I'm actually trying to say here. Okay, so try to be a little bit serious, Bhuvanesh. If you have any questions, concern, okay, ताली बजने के लिए 2 हाथ चाहिए. Sorry to say this. Okay, so if only I am putting efforts, okay, and I'm not getting any clarity from your end, okay, things are not going to be fine. Okay, so that's the reason. Kuch bhi, ask me anything related to data science. Anything. Don't ask me who is going to win the next 2024 election. I'm not good at those kind of things. Okay, but anything related to data science. If you say, Sangmesh, I want to, get this data science, science models into politics and all. Yes, I can do that. I have professionals who are in my team. I mean, who are from Ballari, who work for, BJP and Congress. Okay, who are doing this particular process. Okay, I can
Sir,
basically.
even they require data.
Yeah, they require data. They collect these data from Twitter. They collect this data from this thing. So any what I can say, social media post that you are doing, Modi is good, Modi is bad. All these things are basically getting noticed. Okay, every single tweet that you are doing, okay, is going to count. Okay. We do something called a sentimental analysis. I have done sentimental analysis. Twitter sentimental analysis is possible. So what they do is they have a small kind of dashboards. Okay. So any tweet that you are making, any this thing you are doing, even big companies like Unilever and all, okay, they are also having this. They call this as social media listening tools. They are shelling out really good amount of money. Okay, so for that specific reason, you have to be a little bit cautious whenever you are tweeting. Okay, so I see a lot of people who tweet randomly, but this is the reality. Okay, every single data, every single tweet that you do, they are going to be pulled. They are going to be used. Okay. So, my friend, okay, he's actually not my friend. He's my wife's friend. Okay. He is a very crazy chap. He get into a bus randomly. Okay. He talked to people, okay, randomly on the business, politics, and everything. He tried to get some insights. He will after getting out from that particular bus, he will take all those notes. Okay, what he had told, what was the discussion and everything. Okay, what a person like to speak about, what like to think. Okay, all those things are being captured there. Okay, so these are some kind. We have those kind of people. If possible, we will also try to get those people and do some further analysis. When it comes to data, when it comes to analytics, okay, don't ever think that BJP is not using or Congress is not using, AAP is not using. No, every single company, every single political unit are using this since 2010. Since 2010, they are using this. Okay, that is good. Okay, so what I was actually trying to say is, whenever we have this kind of what I can say data, there are specific preparations of data that is required, and this particular session we are going to try to understand that. Okay, see see, whenever there is data, there are some data inconsistency. Let me speak about the data inconsistency. One is outliers. Can anyone help me out? What is meant by outliers? Yesterday we have discussed outliers, right? Can anyone recall what is meant by outliers? If you are not able to recall, you can say I'm not able to recall, so that I will be able to recall it or explain this.
No, sir, I'm not.
Not able to, sir.
Okay.
Outliers.
See, outliers, I have used this particular outlier word. In your class, there might be one person who is super intelligent. Who is super intelligent? The reason is he is a person who always thinks out of the box. Okay, he is completely a different guy. We call them as outliers. I will give you an example. COVID. I give you an example of COVID. Only in COVID we were using hand sanitizers. Only in COVID we were using mask. That is an outlier. Agree with me? I gave you the same example, right? Outliers. Now you are able to recall. This is
So
called as
I
outlier.
think we didn't. I think yesterday did we discuss? I'm not sure of the outliers. I mean,
So this is it.
sorry.
I gave you the example of mask. I gave you an example of hand sanitizers. So these are called as outliers. See, these normally happen with specific scenarios, like when there is an outbreak. So what I can say. This US do have lot of hurricanes, like floods kind of thing. Okay, so whenever US used to have those kind of floods, okay, there was a specific pattern which was seen, that is, people are buying something called Pop Tarts. There is Pop Tarts, that's a snack people tend to buy only at that particular point in time. So here in India also, whenever there is rain, people tend to eat pakoras. Okay, the first initial rain, people tend to do this. Okay, so these are some kind of observations. These are some kind of outliers. Every single day, here and then, you may eat pakoda, but when it comes to rain, that demand for pakodas and mirchi is going to be a little bit higher on this particular part. See, and along with that, let's assume Zara, H&M, and all these kind of companies, if they are going to provide you a really good discount, then only people will buy. Whenever I give this, many ladies say, yesterday only Zara's, what I can say, offer was there, it got completed and blah, blah, blah. See, whenever there is a discount, there used to be a really good amount of sales, which you can see. What are they? They are outliers. As you are giving discounts, people are buying these things. So for that specific reason, what I'm actually trying to say when I'm speaking about outliers, so for that specific reason, okay, you are you are going to see some outliers. So if you are going to speak about a histogram or something like that, the histogram will be around say like this. Okay. And it is almost going to touch, it is going to have an outlier like this. So these are some kind of observations that a data scientist normally make. So any abnormality, sometimes you may have a data like this when you are going to plot it into a scatter plot or something like that. A data might be something like this. Every single thing is concentrated here, but there is one specific observation which is right here. This is what? This is an outlier. So I'm just showing you how to understand these outliers. One is histogram, one is this thing, or else, you also have something called as box plot. Yesterday we have understood this box plot, right? So you can also use these kind of box plot. So when you have this box plot, you might have these kind of dots. Okay. So even these dots are your outliers. So what I'm going to do is I'm just going to take, okay, this particular screenshot. Okay, let me show you. So I'm just going to click something on a box plot and show you the image. Can you see this? These dots are your outliers. So this is how companies identify that they are outliers. So outliers are very important in an data transformation, because what we do is whenever we find outliers, where is this paint? P-A-I-N-T, paint. Okay. Whenever we have this kind of, what I can say? Okay. Okay, good. So whenever we have this kind of scenario of outliers or something like that, what we do is we do couple of things. Number one, we majorly try to remove that particular outlier. This is the first thing. Eliminating the outlier, identify the outlier and eliminate the outlier. Second thing is transform. So let me speak about these two things, removing and this thing. What I can say, filter it out. So I know every single person what is meant by filtering it out. So what you are going to do is, so let's assume you have a visualization like this, where all of the visualizations are capturing in this particular area. You have an outlier here, let's assume here. So what you are going to do is you are going to filter it out. That is one of the approach that people tend to do. Number two is basically transform. For example, if the transformation we are only going to do when we are having outliers in a very small number, very, very minute number. In that case, we are going to do this. So for example, I have a outlier due to which my data is little bit skewed. Let's assume my whole concentration is little bit towards my positive side. So in those kind of scenarios, we do something called as transformation. What is that particular transformation? We do something called as normalization. We can basically take a note of it. Please make sure. Please take a note of it, because see, these are very important. We do something called as normalization. Okay. So wherein, okay, if the data is completely skewed towards your right, if the data is skewed towards your left, what you do is you try to change this particular thing using the distribution. So you change the distribution using something as normalization. What I was actually trying to say is I was speaking about something called as normalization. If the data is not normally distributed, you bring that particular data into normalization. This is also a part of distribution as well. The same thing. If we have outliers, whether we remove the outliers or do a specific treatment like a normalization treatment for these kind of things. Okay. So please take a note, because in our previous session, I have explained outlier. Okay. And by mistakes, every single person is human. Okay. They tend to make these kind of mistakes. Okay. So
Sir,
I
sorry
don't
to
want.
interrupt you.
Yes, sorry, I'm sorry.
Sir, sorry to interrupt you. I have a question that in basic data analytics language, the outliers are a particular data which changes from others data. These are the value which keeps changing. Is it, sir? The outlier.
Outliers will not change on a continuous basis. For example, I will give you a best example. Okay. Let's assume you have this thing, what I can say, sales. So this is your date and this is your sales. See, what is going to happen is the sales will be like this. One fine day, let's assume we have Deepavali. Let's assume we have Christmas. So these are your outliers. Okay. And whenever an outlier is going to be performed, it is going to be there till the eternity. So this is your Deepavali outlier. This is your Christmas outlier. It's not going to change.
All right. I got it.
Okay.
Okay.
So this happened in, let's assume 2002. Okay. Let's assume it's 2024. Okay. You will be having another outlier. That's it. Okay. So what I was actually trying to inform everyone is, this is the thing that you need to think about. So let me get back to this particular visual. So one is the outlier. You have to filter it out or transform the data. Second is called as missing value. Okay. See, whenever you have data which is missing, so you basically do missing value imputation. For example, see, there are two types of machine learning algorithms. One, you can have missing value. Missing value are okay. There are data science model. There are data science model who don't, require missing value. If you provide a missing value, it will go crazy. I can basically name those, machine learning algorithms as well. Okay. So if you have, decision tree algorithm or something like that, if you have some amount of missing value, it's okay. It's going to understand things. Okay. Similarly, if you have some machine learning algorithms like linear regression and all, if you have missing value, it will go crazy. It will do all the types of dancing. Okay. So for that specific reason, there are some machine learning algorithm which do not require missing value. So you have to treat this missing value. So you have to treat this missing value. How to treat this missing value? So here the central tendency that you have learned yesterday, mean, median, and mode, they are going to be helpful. Because whenever you see a missing value, you try to impute with mean, median, or mode. This stands only true for your numerical data. If you are having a text data, in that case, only mode is the one. What is mode? Anyone can recall what is mode?
A number which comes frequently in the data set.
Most accurate, the number which
Most
occurs more times,
more
frequently
occurring.
occurring, you can say.
Frequently occurring. So that is called as your mode, right? So for that specific reason, okay, when you have text data, you can only apply mode. You don't have any other options. Okay, if you are choosing for central tendency. So these are one of our option. See, why are you choosing whenever you are having missing value? Why are you choosing mean, median, mode? The reason is you don't want to play with the dispersion of the data. For example, if the data is right skewed, or if the data is left skewed, or these kind of things, in those kind of scenarios, if you want to stay with the same distribution, then you are not going to change with this mean, median, and mode. Okay, in that particular case, you will be having the same distribution. So this is a kind of an assumptions that they tend to do. But please make sure whenever you are doing these kind of imputation, you have to be very cautious. I will give you a funny transformation. One of my intern, I gave an assignment to a couple of data scientists. One of our intern who was about to join, she did this particular mistake. What was that particular mistake? Okay, I will try to explain this. So I gave a example, penguins and how many eggs a penguin lay. Okay, so there were some penguins who were laying egg, and there were some penguins which were not laying eggs. There were some missing values. What she did, let me show you. What she did, she basically did all the imputation there. Okay, she basically used a mean imputation there. I asked her only one question. Let's assume you are doing mean imputation. I'm okay with it. Let's assume the penguin is underaged penguin. Let's assume the penguin is a male penguin. How can a male penguin lay an egg? Agree? So for that specific reason, now you are able to get some serious, now you are getting some serious issues here. Whenever you are doing an imputation, whenever you are doing a missing value imputation, you have to be very clear with the data. If you don't look into these kind of things, these are the issues, or these are the problems that you are going to face. Male penguin laying so and so eggs. How can a male penguin lay an egg? How can an underaged penguin lay an egg? So for that specific reason, you have to be a little bit sure on this particular point, points as well. So now people understood how to handle an outlier. People understood how to handle a missing value. Now the distribution. So as I previously told you, okay, whenever you are having skewed data, can anyone help me? What is meant by skewed data? This is something that we have understood previously. Skewed data. Anyone can help me? Skewed data. Anyone?
So this thing that you have taught in the previous session, that something related to data, graphical data, uneven graphical scenario.
Skewed data means anything which is skewed towards your right hand side or skewed towards your left hand side. Left skewed data, right skewed data, they are also called as positively skewed, negatively skewed, where the data is concentrated towards a specific center.
It can be
Okay,
either
not in the
negative
center.
or positive data. Excuse me.
So this is called as, so hope you are able to recall, okay, our previous session. Skewness, this particular thing. We have seen this, right? So this is called as skewness. Okay. So whenever you are having skewed data, there are certain machine learning algorithms. Like one of the assumptions of linear regression model is the data need to be normalized. When you have a skewed data and a machine learning algorithm is requiring the data in this particular fashion, things will go blah blah blah. So for that specific reason, we do normalization. There are various types of normalization, log normalization, and all these kind of things, degree of normalizations. So what we do is we use something called as normalization. We use this normalization and bring a skewed data to a normally distributed fashion. There are some statistical transformations which are actually required. That is something that you can do. Normalization is one of option. Okay, using normalization, we can bring a skewed data into a normally distributed fashion. Something like this. Adding to this is one type of transformation. Similarly, let me give you another example. This is related to something called a standardization. So let's assume standardization. So let's assume, I'm just giving you a small idea here. Okay. You have a column called as age. And you also have a column called as sales. Okay, this is a second column. And along with that, you also have something called as profit. So age, a human age, it will be between units and tens, right? No one will have something like 150 age, 5,000 years old, something like that, right? So normally when I speak about age, it will be units and tens. Agree with me? Similarly, when I speak about sales, sales might be 1 rupee also, unit tens, 1,000, okay, 10,000, lakh, and all these kind of things. All the units will be available here. Similarly, profit will be little lower. Okay, unit tens, 1,000, 10,000. Let's say in this particular part. See here, what I'm actually trying to say is I'm speaking about the number of units. Okay, so for example, 15, 20, 25 age is something like this. But when it comes to sales, so it might be 1 lakh, 10 lakh, 15,000, 10,000, something like this. I'm just going to, so sales can vary, right? Agree with me? Similarly, profit might be a little lower. For example, if it is 1, it is going to be 0.25 paise. So if it is going to be 1 lakh, it's going to be 5,000, something like this. I'm just giving you some rough idea. It will be little lesser than your sales itself. See what is happening here. Let's try to understand. So you have various types of scales. You have various types of scales, as in you have units and tens here. You have the unit, tens, lakhs, thousands, and all these kind of variations here. And profit is also some things which is also varying a lot. See, what I'm actually trying to inform everyone here is, so as there is lot of variations here, if you try to plot a visualization, it is going to have lot of dispersion. Okay, it will be having lot of dispersion. So there are certain machine learning algorithms like k-means and all, which are used for clustering and all these kind of things. So whenever you have a data like this, okay, there will be lot of distance, like one will be in Kashmir and another will be in Kanyakumari and third will be in Manipur and fourth will be in Jaisalmer. Try to understand. So the distance will be really huge. Okay. And trying to fit everything into one small visualization can be a little bit difficult. Agree with me? Do you agree with me? So, for example, if I want to show some values, okay, one is in Kashmir, one is in Jaisalmer, one is in Kanyakumari, one is in Manipur. It's really huge. So, for that specific reason, what we do is we try to do something called as standardization. Okay, so there are a lot of types of standardization. There is something called as Z-score, scaling, and all these kind of things that we tend to do. What we do is, so right now, hope you are able to see the distance between all of them is really huge. The distance between all of them is really huge. Now, what we do is, using something called as scaling, we basically convert everything between 0 to 1 or -1 to +1. So we basically get the whole thing into this particular range. Now you might be saying, hey, Sangmesh, I have age. And if I'm going to convert all this age between -1 to +1 or 0 to 1, what is going to, there will be a lot of loss of information. Agree with me? If there is a age called as 15. So if I'm going to change this age, this particular age to 0.543, something like this, do you think it is going to make any kind of meaning? Yes or no? Is it going to make, so for example, I have an age called as 15. I'm going to convert this into a number, okay, using some kind of normalization, extremely sorry, the scaling transformation, and I basically transform this particular data into a random number like this. Are you able to make any sense here? Yes or no? Try to be genuine here. And if I'm going to call this 20 as something like 0.853, something like this, will you be able to make some understanding? Yes or no? You will be able to make any kind of understanding? No, right? No, right? You won't be able to understand anything, right? The essence of the meaning. For example, if your age, what is your age? That is 15, right? For example, if I'm going to turn your age to 0.5432, something like that, will that make any sense? So if Amjad, what is your age? If he is going to say some age, instead of his age, I'm going to give some random number like 0.5486, something like that. Amjad will make any sense? Amjad will say, hey, Sangmesh, what are you saying? My age is so and so. You are saying some random number which is also not matching with my date of birth as well. Agree with me?
Yeah,
Agree with me? So you may not be able to identify this. You may not be able to understand this particular thing, but machines are capable to understand these things. Machines are able to understand these things. By using scaling, there will be transformation like this, which will happen, and the same information is going to be plotted in a small distance like this. There is no information loss. That is the part of this particular standardization process. Big visualizations may not be really good. So for that specific reason, they are going to be shrinked into small things like this, wherein you may not be able to identify some random numbers like this, but machines will be able to use this particular random numbers to plot things. And on this particular visualization, you are going to do some analysis like k-means and all these kind of things. Okay, so this is the reason what is meant by a standardization. I hope you are able to understand what I'm actually trying to say.
Yes, sir.
Okay. So this is everything. Yes, yes. Any questions?
A small question, sir.
Sure, sure.
Could you please repeat the correlation in skewed data to normalization to standardization in the one line? That how we are,
Normalization.
yeah, how we are moving from skewed data to normalization to standardization.
See,
Short.
can you type your question so that I'm able to understand this? I'm really sorry. The voice was not that
I'm
clear.
happy.
The voice was not clear. Any other questions, you can let me know. I'm there to help you out. So I'm sorry, I'm waiting. I'm on a standby. Okay, I want your question. Could you please correlate the skewed data to normalization to standardization? Sure, happy to help you. Sure, happy to help you. Okay. Skewed data. First, let's try to understand the skewed data. What is meant by skewed data? Skewed data means where the concentration is more. I will give you some live examples so that you will be also able to relate with this. Okay, let's speak about the skewed data. Okay, so let's assume people who eats chocolate. Okay, people who eats chocolate. And let's assume this is your age. Bottom is age. Okay, this both this particular thing. Okay, so this particular visualization who eats chocolate. Okay, so these days no kids are eating chocolates. They are all hooked up to Lays and Kurkure. That is a different saga. But let's assume in our area, in our domain, like way back in 1980s, 1990s, 2000, most of the kids used to love chocolates when they were in young age. See, what I'm actually trying to say is, okay, this is this particular age, what I can say, visualization. Okay, and normally people who are young, okay, between something like 5 years to something like 25 years, people are eating this thing, what I can say, chocolates. And post this, no one is eating chocolates. Something like this. Okay, this is one of a observation. Now let's have another observation. People who are having BP and sugar. So here what is actually happening, normally people will not have all these kind of scenarios till they are having something like what I can say 35, 40 years. Till 40 years, normally Indians, till 40 years, there won't be any this thing, what I can say, this kind of scenarios. Okay. So till when they cross 40, they tend to have all these kind of problems. Okay. So what I'm actually trying to say is, look at this. One visualization is skewed towards your this side, and another skewness is basically skewed towards this side. Okay, this particular BP sugar is skewed toward this side, and chocolates are skewed towards this side. So this is actual data. This is 100% actual data. Okay. And this is a practical example what is actually having around you. What goes around you. I'm just giving you a small idea. Okay. So now as we have this kind of this thing, what I can say, distribution. So what this normal distribution will do is normal distribution will transform this particular data. Okay, so there is a huge complicated, what I can say, formula which is behind this, that is called as normalization. So what this normalization will do is the normalization will basically get this particular data into something called as bell-shaped curve. Bell-shaped curve. So this is called as normalization. What is normalization? That's the reason it's called as normally distributed fashion. If you are bringing a data which is skewed, you are going to bring it to a normalization. So here you have this age, right? The age, here also you will be having the age, but instead of 5 to 25, it will be having some more, some random numbers itself. You won't be able to identify those numbers, but it will be transforming the data. Okay, so what it is going to do is, okay, so it's a really really interesting thing. What I want to do is, there is a really good YouTube video. Okay, they say how a histogram, look at this. In that particular video, let's assume you are having a histogram like this. Okay, so how a normally density, how a normal visualization or a density plot is normally plotted, they will show. So here, if you are going to have a data which is, look at this, which is log normally distributed, it will start from here. It will touch from here, due to which the data will be a little bit smoother. Okay, there is a really good YouTube video. If you have a, what I can say, chance, you can watch that particular YouTube video. It's really interesting. It will show you how a normalization will work. Okay. So this is called as normalization. Standardization is, in another hand, it's a completely different scenario. So standardization is applied only when you are playing with different units. Like, for example, you have temperature, you have age, you have something like a score. So these are some completely different this thing, what I can say, combinations. So in those kind of scenarios, you use standardization. I think Ansari got some clarity on this particular part.
Yes, sir. Yeah.
Okay. So this is everything related to this particular part. And here, okay, you have to look into the transformations. So these are some kind of transformations that you always need to keep and always need to think about it. Okay, whenever you are creating your machine learning. See, every single machine learning algorithm I'm speaking about, every single machine learning algorithm do have something called as assumptions. So whenever I'm going to teach your machine learning algorithm, it is my duty to share you what are the assumptions. Every single machine learning algorithms are having some underlying assumptions, and you have to follow those assumptions. If you don't follow those assumptions, what is going to happen is, okay, there might be some issues that you may face. The accuracy is not going to be proper, or you may get some error. So these are some kind of issues that you may face. Okay.
All right.
Okay. So that is it for today. In our next session, we are going to get our hands dirty. Okay, on something called as inferential statistics. We have learned what is meant by inferential statistics. Can anyone recall what is meant by inferential statistics? Can anyone help me what is meant by inferential statistics? If you are able to remember, you let me know. Inferential statistics.
You have taught us about the inferential statistics.
Inferential statistics is all about a relationship between two columns. relationship between 2 columns, 3 columns, 4 columns, relationship with, this comes under what? Diagnostic analysis. This comes under something called as diagnostic analysis. We will be looking into that particular part. Okay. Okay. So for our next session, okay, to calculate this hypothesis, to calculate this, what I can say, inferential statistics. Inferential statistics is all about calculating, correlation and everything. So, I am giving you two options because these are some things that are very important. Okay. So first, we will learn Python or first we will learn Excel. You give me a choice. You say Sangmesh, no Sangmesh, because see, I am not interested to teach, okay, this inferential statistics directly, because this inferential statistics is something, mean median mode is was one single line calculations that you can do, you can learn. I'm not worried about that. But what I'm worried is, okay, I want everyone to do this particular activity, that is, okay, inferential statistics, because as a data analyst, you do this particular activity, the inferential statistics. Okay, so now you let me know. You want to do this particular inferential statistics on, what I can say, Excel, or inferential statistics on, what I can say, Python. You let me know. I will be there to help you out, because see, I am just giving you an option. The reason is I want to modify this. So if I go to this particular this thing, what I can say, syllabus. Look at this. So we are going to understand the introduction of data analytics, and we are almost done with this particular inferential data analytics. So we are going to look
Sir,
into the
you have not shared the
inferential.
screen.
Sorry?
Screen sharing.
I'm really sorry. I'm really sorry.
No problem.
Okay. I think I was sharing my screen. Okay.
Yeah.
So what we have done is we have understood this introduction to data analytics. Okay, all these things are understood. So this is the part which is left out. Okay, that is inferential statistics. Okay, probability, correlations, data cleaning, and all these kind of things. Okay, so what I was thinking is I want to do some practicals on this particular part. So just having this particular understanding is not good. Okay, understanding how to do it, how to apply it is something what I was looking for. So for that specific reason, I'm going to give you two options. Number one, if you want to learn the same things, after Excel, I'm there to help you out. So if you want to learn the same thing after understanding the Python basics, okay, so you can choose it. I'm ready to do that. And what I'm doing is I will cover all the this thing, what is the topics, but here, okay, I'm just going to do some here and there. Is it good? Or if you say no, Sangmesh, that is absolutely fine. Let's follow the course content itself. We will also do that. Everything is your, what I can say, comfortability. Or if you are not able to decide something, you can say, Sangmesh, I'm not able to decide. You suggest me the best approach. I will also suggest you the best approach.
Yes, sir. Let us know best approach.
Okay.
I'm
See,
particularly not able to.
Things will
Rest
get
of the
more and more clear once we go ahead. Once we learn
okay.
so and so. And
Okay.
I'm sorry that I am your weak student. That's why I take more time.
No, it's
Yes.
fine.
So when it comes to best approach, what I say is, see, most of the companies these days are using, what I can say, Python normally. Even see, inferential statistics can be done using Excel also. Inferential statistics can be done using Python also. Okay. So what I say is Python is a best choice. The reason is, today you may have a small data, tomorrow you may have a big data. Okay, so in both the scenarios, Python is going to be an inevitable, what I can say, tool. Okay, so for that specific reason, I'm assuming that Python is going to be a best justice for your career. Okay, so I want to go ahead But if you want me to do any kind of changes, you can let me know. I'm there to look into that. Okay. So it is your duty. Okay. So when we complete our Python training, it's your duty. You have to ask me, Sanmesh, you told me that, you are going to take inferential statistics post learning Python. You have to keep this particular thing in your mind, and you have to reach me. If I'm also a human, guys, I may also live or forget something. So if I'm forgetting something, it's your duty to help me. Okay. Sure. So now I want to inform, Apshala team that, the next session that we are going to take will be on Python. Okay. If people are agreeing, or if they say, Sanmesh, we will go ahead with Excel, we'll go ahead with Excel. Okay. So I'm not worried about the technology, but I'm worried about the concepts here. Okay. I want to do some practicals on this particular part. Okay.
So choosing Excel or Python is
Mhm.
is optional, or we have to take both things.
Both is going to be a little bit difficult, Ansari ji.
Okay.
Sir,
Both.
first we need to learn Excel, or it is better to go with Python and then Excel?
Anything is fine. Anything is fine.
Okay.
I
Okay.
agree with Mr. Abhishek.
Sorry, Amjad.
I agree with you, sir. I agree with you.
Okay,
Firstly,
okay.
we should go for the Excel, then we will move Python, sir.
Okay, we will learn Excel, then we will go for Python.
Yes, sir.
Okay.
Yes.
So after learning Excel, after learning Python, then you want to learn inferential statistics, or after learning Excel, we will learn inferential statistics.
Then
Sir, as you said
Then
before,
Python is the
that
best.
better is Python, so maybe after Python.
Okay, let's do something like this. Let's do something like this. First
Or
learn Excel.
Can we
First
have
learn
any?
Excel.
Yeah, sorry.
Okay.
Yeah.
Let's learn Excel.
Hmm.
Then we will learn Python. Then we will learn inferential statistics. How is it?
Okay.
Deal? Deal? Okay, beautiful.
All right,
Next
sir.
session will be completely based on Excel. Okay, we will learn Excel, and then we will go for, what I can say,
Influential.
Python, and then we
Python.
will do the inferential statistics.
Sir,
Okay.
my suggestion,
Mhm.
one, if it is possible, can we have one practical in Excel of influential statistics?
100%.
Or
Difficult. Okay, difficult. But I will just give you a small glimpse where to do, how to do it. Okay, can you do it? Can you do a DIY project? Do it yourself project? Can we have that? I will be able to show you how it is done. You have to do it on your own. Okay.
Okay.
So I will activate your data analytics tool pack. So there is a specific tool pack that is required for in Excel. I will activate your data analytics tool pack, and I will show you how it is done. And it's your task how to do it, and how
After
to go
learning
ahead.
Python,
Okay.
we'll have more clarity. Yeah.
Sure.
Okay.
Good. All good, guys. Then we will catch up in the next session that is going to be on Monday. Okay. We will try to do this particular activity. Okay. Have a great day. It was a great learning. Okay. And try to interact like this. It will also give me motivation and clarity as well. Okay. So Apshala, Kamal, just try to understand that we will be understanding Excel in the next session, and then we will be doing the Python, and then we will be doing the inferential statistics. We are just reordering the structure. That's it. Okay. Okay, guys. Bye. Have a great day. I think
Thank you,
he's
sir.
on mute.